Okay, so we are on reporting category 1, matter and energy. And atoms are the smallest unit of matter. We cannot break an atom down into anything smaller. In other words, we can't take oxygen and make oxygen into baby oxygens. It just doesn't work like that. So atoms are the smallest unit of matter. All right, here's our pen table, and we want to make sure that we copy this on our periodic table before we ever start taking our STAAR test. And because this is really going to answer a lot of questions for you about chemistry as far as how an atom is made up. So there's 3 parts to an atom. There's protons, electrons, and neutrons. So let's look at our proton. Our proton has a mass of 1, and our protons are positive, and they live in the nucleus. Well, here we have a subatomic particle here that has a mass of 1. It doesn't have a charge, so we know right away that that is the neutron, because the neutron does not have a charge. And where is it located? It hangs out with the proton in the nucleus. All right, the electron has a mass of let me make that decimal point bigger for you, 0.001. It has such a small mass that we don't count the electron in the atomic mass. We only count protons and neutrons. Electrons have a negative charge. They're not allowed to come to the party with the protons and neutrons in the nucleus because they're negative. And so where do they live? They live in the electron cloud. They're orbiting, they're going around, they're revolving around the nucleus. All right, so here you were asked to draw an atom that has 4 protons. Now, you could have used a plus sign or you could have used a P. It didn't matter to me, but as long as you identified it in the key. So if I have 4 protons, I know that those protons live in the nucleus. So there's my 4 protons. I have 5 neutrons, and I'm going to draw those with a 0 with a line through it. And I need 5 of them. There we go. And I need 4 electrons. So assuming that this line is sort of showing you where the nucleus is and that this would be the first energy level, I'm going to put 1 negative electron there and 1 negative electron there. But that's the first energy level. And the first energy level can only hold 2 electrons. So I've got to take the other 2 electrons to the very next energy level, the second energy level. And now, do I have 4 electrons total? Yes, I do. And that's how you draw that atom. All right, atomic structure. We have our electrons, which are negative, and they are on the electron shells. We have neutrons, which don't have a charge at all, which are these empty spaces. We have protons, which are positive. And the protons and neutrons are inside of the nucleus, and the electrons are orbiting around in these electron shells, or energy levels. They have several different names. So what do protons tell us? Very important. Protons tell us the name of the atom. And it's very hard to write with my mouse, but I'm trying my best. And so the word is identity. Identity. Now on your paper, you'll notice there was an error, because that element with its 4 protons would be beryllium, not boron. Boron has 5 protons. So in actuality, we caught an error there, didn't we? This is actually beryllium with an atomic number of 4, because 4 protons. Remember that protons tell you the atomic number, and that's what tells you the name of the atom that you're dealing with. All right. Energy levels or valence shells. Valence electrons are those electrons on the outermost energy level. So on this one, we'd have 1, 2, 3, 4, 5, 6, 7 valence electrons here. Valence electrons determine the reactivity of an atom. The reactivity of an atom. They tell you how that atom is going to react or act when it meets another element. So it determines an element's chemical properties, including its reactivity, which means how it's going to combine, if it does combine with other elements. So the first energy level, as you see here, can only hold up to 2 valence electrons. I like to think of this as like an auditorium. The first row only has 2 seats. So if I have 17 students, I can only put 2 on the first row, the first energy level. The second energy level can only hold up to 8 valence electrons. So I can put 8 students on the second energy level. Just like an auditorium, if the second row only had 8 seats, I can only sit 8 students there. Once that's full, then I have to go to the third row, or the third energy level, which can hold up to 8. And in this case, I can put my remaining 7 students right here on the third row in our auditorium. All right, 8-man, very important. This is another thing that I would like for you to write down on your periodic table before you ever even start answering questions. So the A stands for, and I'm going to use some abbreviations here, it stands for atomic number. It's not a hashtag sign, it's a number sign, which tells me protons and electrons. I have to have the same amount of positive protons as I do negative electrons. So, for instance, let's look at aluminum right over here. Aluminum has an atomic number of 13. So it's going to have 13 protons and 13 electrons. They're going to be the same number. This is saying mass. The man says mass minus your atomic number, so it's your bottom number minus the top number, and remember, we always round. That's very important, and it's also a beautiful thing because we do not want to deal with these decimals down here. If you subtract your mass minus your atomic number, that gives me neutrons. So that tells me how many neutrons I have. In this particular periodic table, they don't even give you the mass, but on your periodic table you will, and you will need to round to a whole number. Now I do want you to notice on this periodic table that one of the other things that I want you to do before you ever start testing is I want you to highlight that bolded line. So let me see if I can come down here and get a highlighter, and I'm going to actually highlight the bolded line right here. Okay, I'm going to highlight that. Once I've highlighted that, then I am going to draw an arrow to the left. And I'm going to write the word metals. And that's going to remind me that all my metals are to the left of the staircase. Now, notice hydrogen. Hydrogen's an exception. It is a non-metal. It's a gas. It's not reactive. And it's not as reactive, let's put it this way, it does react. And hydrogen has 1 valence electron, which is why it's in group 1, and we'll talk about that in just a moment. You'll also notice aluminum. Aluminum has 2 sides that touch the zigzag line, but it is indeed a metal. And I remember that because aluminum foil is shiny, it has high luster, it's very malleable, it's bendable, it looks like a metal, well, because it is one. Then I want you to draw another arrow to the right of the zigzag line, and I want you to label that non-metals. And then on the zigzag line right here, I want you to put the term metalloids. And I'm not going to write it out because it's going to take me too long, but boron, silicon, germanium, arsenic, antimony, tellurium, and polonium, those are all your metalloids. They share properties of metals and non-metals. Okay, rows on the periodic table are called periods. That's very important to remember. They are the rows. Columns on the periodic table are called groups. Sometimes you'll hear them called families. Okay? So let's look at a little shortcut we can use to remember that. If you guys will remember, I had you draw an axis, and I had you label that G and P. And actually, one of my students came up with this idea, and I thought it was brilliant. G comes before P in the alphabet. And so therefore, G is my groups, those are my columns, and my periods are my rows. Just a really short and fast way to remember that groups are columns and periods are rows on the periodic table. Elements in the same group or family, and this is This is so important. Let me highlight that. Elements in the same group or family have similar properties because they have the same number of valence electrons. Remember, valence electrons tell us reactivity. So these guys are going to react all the same way because they have the same number of valence electrons. And if we'll go back and look at that, on our periodic table, what's really cool about our periodic table is this. One, you're going to be given a sample box right here, and it's going to tell you that the top number is the atomic number and the bottom number is the atomic mass. That is a beautiful thing. You don't even have to remember which one's which because it will tell you. You just have to remember 8, ma'am, and what it means. Also, on your periodic table, you will see these numbers right here. But what's really neat is that right below them, it'll look like this. It'll have the group number of 13, but then it's going to have a number that looks like this, 3A. You're going to look at that 3A. That 3 tells you there's 3 valence electrons for every element that's in this group, in group 13. This will say 14 with a 4A underneath it. The 4 tells you that every element in group 14, all of these elements have 4 valence electrons. Group 15 will have 5A underneath it, 5 valence electrons. It goes on from like that. All right, atomic number is the top number in the periodic table in the element box. And what does the atomic number tell us? Well, if we go back and look at our notes, it tells us protons and electrons. They're going to be the same number. All right, atomic mass is going to be my protons and plus my neutrons. Remember, protons and neutrons hang out together. They like each other. And they hang out in the nucleus together. Okay, my mouse is going a little crazy here. They hang out together. So what are you going to do? You're going to add your protons and neutrons. So if you get a question that says I have 4 protons and I have 5 neutrons, what's my atomic mass? Well, 4 plus 5 is 9. My mass would be 9. How many groups or families do I have on the table? Groups are my columns. So when I go back and I look at this, my columns, I have 18. So I have 18 groups on the periodic table. How many periods? Well, down here I remember periods are my rows. And so when I go back, I can see that I have 1, 2, 3, 4, 5, 6, 7 rows, 7 periods on the periodic table. Some of you may be wondering, if groups tell me valence electrons, what do periods tell me? Well, every element that's on the same period has the same number of energy levels. I don't think you're going to be asked that on the STAAR test, but it's good to know. So every element on group 1, which is just hydrogen and helium, has 1 energy level. Every element on group 2 has 2 energy levels. Every element on group 7 has 7 energy levels. All right, moving on. Let's go to our practice. Which 2 elements are the most similar? So what am I going to highlight here? I highlighted the 2 elements that are the most similar. Similar means that I am dealing with my groups. I know that elements that are in the same groups have the same reactivity. They have the same chemical properties. So let's look for iron and cobalt. Let's go back to our periodic table. Iron is right here, and cobalt is right next to it, elements 26 and 27. They're on the same period, but they are not on the same. So I'm going to put a P there, and I'm going to mark that out. Let's look for lithium and fluorine. Lithium and fluorine, well, here's fluorine, and here's lithium. They're on the same period, but that has nothing to do with being the most similar. As a matter of fact, lithium's a metal and fluorine's a nonmetal. All right, let's look for copper and silver. Here's copper and here's silver, and they are in group 11. So that's a beautiful thing. So I'm going to put a G and I'm going to put an 11 by it to remind me that they are in group 11. So that could be an answer choice. Let's rule out hydrogen and oxygen. Hydrogen is here. Oxygen is here. Gosh, they have nothing in common really other than the fact that they're non-metals. So we're going to rule that out. So your best answer choice was copper and silver. All right, what are metalloids? I'm going to highlight metalloids. And what do I know about metalloids? I know that metalloids share properties with metals and nonmetals. I know that. So, the metal elements with small atomic numbers, no. They're not metals at all. The elements between the metals and nonmetals on the periodic table, well, let's look at that. Are they in between the metals and the nonmetals? Yes, they are. So that could be an answer. Chunks of metal ore, well, they're not metal. They're not metal. Non-reactive metal elements, they're not metals. They are in between. So your best answer choice was right here. It was B. All right, here we go. Highlighter. Which of the following elements is the least reactive metal? Well, I know that any metal that's in group 1 or 2 is going to be very reactive. So let's find potassium. Potassium is a K. Is it in group 1? Yes, it is. Therefore, it is very reactive because it is in group 1. We don't want anything in group 1 or 2 because those are very, very reactive. All right, calcium. Calcium is in group 2. So calcium's out because it is in group 2. All right, let's look for manganese. Mn. Mn should be somewhere right here. It's in group 7. So I have group 7 here. And zinc. Let's go find zinc. Zinc is going to be right here. It's in group 12. It's in group 12. So I've got group 12 and group 7. How do I choose between them? Well, they're the furthest away, so zinc would be the least reactive metal. So zinc is going to be your answer choice. All right, which of the following is a noble gas? And I need to highlight that. Noble gas. Well, I know that the noble gases are those special gases that are found in group 18. And the reason why they're called noble gases is because their energy levels are full. They will never react with another element. They don't have to give or take valence electrons. They're full. So let's look for neon. Is neon? Why, yes, it is. It is in group 18. So yes, that checks. Let's look for nitrogen. Nitrogen is in group 15. So that's not a noble gas. No. Let's look for oxygen. Oxygen is here, and it is in group 16. So that cannot be right. And I know that hydrogen's in group 1, so that's not right. So my best answer choice was neon. All right, well, I hope this helps you, and good luck. Just remember your pen table because that's what's going to help you the most. Good luck on STAAR. We're proud of you.